Hi, Matthew.
Hello.
Um, I think you were interested in joining the COP 3530 course staff, right?
Yes.
Yes, great, great, great. So I wanted to ask you a question before we make our final judgment on the course staff decisions. Do you want to proceed with the technical question?
Of course.
Absolutely. So let's get started. So you are given a string, which I'm calling digits. And this string consists of only numbers and has some length that is n. Uh, the digits could be something like 0, 1, 2, 3, or it could be any digits from 0 to 9, and the length could be n, where it could have n digits. So what I want you to do is to write some code that can extract uh, numbers, which are integers, that are comprised of uh, digits which follow four conditions. So I'm going to give you those four conditions. The first condition is that the numbers that you extract consist of four digits. Okay. The second condition is they should have no leading zeros. The third condition is the number should be odd. And the fourth one is all the numbers should be unique.
Okay.
And formed of unique digits. Do you want me to show you an example?
Sure.
Would that help?
Yes.
Okay, awesome. So let's say if we have this string, which is 0, 1, 2, 3. In this case, what I want you to do is to return a sorted array consisting of all four-digit numbers that follow these four conditions, which is, for this case, it would be 1, 0, 2, 3, 1, 2, 0, 3, 2, 0, 1, 3, 2, 0, 3, 1, 2, 1, 0, 3, then 2, 3, 0, 1, and 3, 0, 2, 1. I think there'll be one more, which is 3, 2, 0, 1. So as you can see, like, these numbers are all four digits. They don't have any leading zeros. All of them are odd, which is 3, 3, 3, 1, 3, 2, sorry, 1, 1, 1, and all of them are unique. Did you get this question?
I see. Yes.
All right. So do you want to proceed and show me, how would you go about solving this?
Sure. I think just before I continue, I might just have some questions. So
Yes.
is digits always going to have at least four?
Yes. So you can assume that the string, which is called digits, will at least have four characters.
Okay.
Okay.
Okay. Yes. So I think I see a solution. So I'm just going to run it by you first.
Sure.
So my first instinct is to just go and enumerate through each tuple of four characters of digits. And once we have those four digits, we already satisfy the first condition. Then we just have to check the second, no leading zeros, no odd numbers, and they're all unique.
Okay.
So that's my solution. And then once we enumerate through all of them and they satisfy those conditions, we're going to put that in an array, and then we're going to sort it and return it.
Okay. So just to clarify, which is, in case if you have more than four digits, for this example, I think your technique is going to work.
Yes.
But let's say if it had more than four digits, which is instead of 0, 1, 2, 3, it was 0, 1, 2, 3 up to 9. In that case, will you still enumerate four-digit numbers or something else?
Yes. So I'll just pick four distinct indices each time.
Okay.
And then if they satisfy them, then I'll add them to the array.
Okay. Makes
Yes.
sense. Makes sense. Thanks.
All right. So I'll just create some function, and I'll be writing in pseudocode if that's all right.
Sure, that's
Yes.
absolutely fine.
So gonna have some function, and we're just gonna say it's called 4 digits. 4 digits, and it's gonna take in that string digits. All right, and like I said, we're gonna want an array to store all the numbers that we can have. So let's just call this array answer. And we're also going to have a set. So we want to make sure that whenever there's a number that satisfies these three conditions, we're not adding the same number again.
Okay.
So we're going to have a set to keep track of all the numbers that we've currently added. So
Okay.
set, and we're just going to call this current nums. So we have these, and now we're prepared to just go ahead and enumerate through each tuple. So we're going to have our first for loop for I equal to 0, and this is going to go up to, let's just say, digits.size. Digits.size. And then we're just going to increment I by 1.
Mm-hmm.
And we're going to do the same for the next index. So for j is equal to 0, and then digits dot size, and then of course increment j, and then another time for the third index for k equal to 0, again up to the size, and then we're going to increment k, and then one more time for the last index, which we'll call L. 0 digits dot size, and then increment L once. So now we're in this for loop, and we know that it's going to be 4 digits since we have these 4 indices.
Mm-hmm.
And then we're going to want to check if these 3 are satisfied.
Okay.
So first we're going to just check, is this leading digit, which would just be led by I,
Mm-hmm.
Is that a 0? So if digits I, which is the character at I,
Mm-hmm.
so if that is a 0, then we're just going to continue because we don't want to consider that number.
Okay, that's good.
And then we're going to want to make sure that it's odd. So to do that, we're going to actually need to form the number first now. So we'll have this int, which we'll call num, and we're just going to form that by concatenating these characters together, and then we're just going to assume that we have some toString function. So to string, and then we're just going to go digits I plus digits, what's that, j, digits k, and then digits L. So this is just going to be concatenated to one string.
Okay.
And then actually, not a toString method. I'm going to erase that. A toInt, let's just call it. Yes, toInt. So now we have the numerical representation of our number, and we're going to say, is it odd? And if it's even, then when it's divided by 2, its remainder is 0. So we can just do that with the modulo operator. So if num mod 2 is 0, then it's even, and we don't want to consider that, so we just continue.
Okay.
Continue. And now we have our last condition that we want to satisfy, which is we want to make sure that none of these indices are the same, and that we haven't already added it. So we can just do that by comparing each one of these indices. So if I is equal to j, or I equal to k, or I equal to L, and then the same for the next, or j is equal to k, or j is equal to L, and then the last index, or k is equal to L. So now we've done that to make sure that all of the characters are distinct. Continue if they're not distinct.
Okay.
And then our last one, we just check if this num is in the current nums, then once again, we're going to want to continue. And if none of these conditions are satisfied, then we satisfy all those 4 conditions. So we're going to add it to answer. So answer dot add num. And then we're also going to want it to the current nums. So current nums, and then we're going to add that. And then that's it. So what we're going to want to do at the end, once we finish this enumeration, is we're going to use some built-in sorting function to sort the answer. So sort answer and then we're just going to return answer. So return answer. Oops.
All right.
Yes.
Okay. So I have a couple of questions for you. First of all, like, do you want to walk me through one of the examples, like how it's
Sure.
going to proceed?
Yes, so I can just walk you through this one. So initially, all the indices are set to this, the first index, and then eventually they get moved along so that they're all different indices since they can't be equal. So the first instance of where that is true is when I is equal to 0, and then j is 1, k is 2, and then L is 3. So we have just this 0, 1, 2, 3 here. But as you'll notice, digits I is equal to 0, so we would just skip that.
Okay.
So the next thing that we would go over is we would increment the j, so let's just keep this up here. I is 0, j is 1, k was 2, and then L was 3. But we finished this for loop, so now k now becomes, what is that, 3? And then now we consider L 1 is equal to 2, so that they're all distinct.
Okay.
And so now we would have 0, and then yes, 1, 2, 3. And we're essentially just going to get this exact same, okay, well, the first character is 0 for each time that I is equal to 0. So next, we consider I is equal to 1. And then we can consider j equal to 0, and then k equal 2, and L equals 2, 3.
Okay.
So yes, this is what we have now. And yeah, you should also notice that since this example is nice and simple, the indices also align with the characters.
Okay.
So this is the characters that they represent, and the number that they represent would be 1023. And we see that I is not 0, so we're good to go. And then we also see that 1023 is not even. And then we also see they're all distinct. And since we haven't added anything, it's not in current nums. So let's just say current nums. And this is it so far. And then our answer, so far, it just consists of 1023.
Okay.
Which is also in there. So
okay.
we know that it's adding the correct one now. So now the L for loop is done, so it gets reset. And then K goes to 3. And then we have L at 2. But then you'll notice 10, 22, that's even, so we don't consider that.
Okay.
And then I think, yes, 10, 22. Yeah, so it's even, we don't consider that. So then what else do we go to? So this was 2.
I think we'll change the I to 2 now.
Oh yeah, that's true. Okay.
Sorry, J to 2.
Yes, so then we would change J to 1, but then that's already taken up, so then we have J 2. And then we would have K for 0, and then L for 3.
Right.
So then we would see 1203, it satisfies all of those conditions in there, and we haven't added it yet. Oh, I forgot to add 1023 to the current nums. But yes.
Okay.
So we have 1203, which satisfies all those conditions, and we haven't added it. So we're adding that to our answer, as well as the current nums. Yeah, so then we would continue 1203, that's finished. 112, and then I think 3, and then 0. Yes.
Yeah, I think I got it.
Yeah.
Thank you so much.
Okay, yeah.
This is
So
great.
then it would essentially just continue, and all of these would be added.
And what's the time complexity of the solution?
Okay, so I can go through the time complexity, yes. So these first two statements are both of 1 since we're just declaring them. And then we have this quadruple for loop. And within the final for loop, everything here is an O of 1 operation since we're just doing a comparative operator. And then we're just concatenating this string and converting it to an int. Then again, we're just doing this continuing comparing, and then adding to the vector since we're adding to the end of the array, and then we're adding to just this set. Those are both O of 1 operations.
Okay.
So this for loop where for L is just O of 1, and then from there we can say that since it's a quadruple for loop and we're iterating through the digit size each time for each embedded one, this entire thing is O of n to the 4.
Great.
O of n to the 4, and then we're sorting that. That's O n log n, but since O of n to the 4 is much larger, we don't contain that in the entire time complexity. So for time, this is of n to the 4.
Yeah, and what about the space complexity in this case?
Sure. So the space complexity is actually reliant on digits. So we're just going to say space, and then, like we said, we're only adding the current nums that satisfy all of these conditions. And so if we look at the first example, that was just 4, but then there were a bunch in here, so there were all of those. So I think for the space complexity, I would say in the worst case, each one of these is satisfied. So I think a generous upper bound would also be something like of n to the 4.
Okay, makes sense. So before we move to a more optimized solution that you might be interested in working out, I had one other question, which is, what do you think should be the output for this program? Let's say if digits was 1111, which is like, again, 4 digits, but all of them are ones, which is repetiting. So in this case, based on the conditions, what should be the output array consist of?
Well, I think let's just look at, well, the only thing that can be concatenated here is just 1111. So there are 4 digits, no leading zeros, it's odd, and they're all unique indices. So I think the answer should just be 111.
Okay, but one of the constraints that I added for the 4th one, maybe you misunderstood this, was to allow only unique digits because these digits are repetitive, right?
Oh,
So
I
in this
see.
case, it should give you back an empty array. So assuming now that you know that we only have to return back unique digits, which is um, all of the 4 digits should be unique. In that case, what modification will you do here to make that
Okay.
possible?
Well, in that case, I think we can also just add something here to this. We can add another if statement, or we can just add it here, and we can just check digits I, digits J, digits K, and digits L. If they're all different, then we'll continue with the rest of the for loop. But if they are the same, then we won't consider the number.
Great.
So
great.
in this case, yeah, we see clearly 1 is equal to 1, so we won't add it.
Okay, makes sense. That's wonderful.
Yes.
So do you want to show us, how do we approach the more optimized solution? Can we optimize this further?
Sure. I think if we look at our previous solution, the real bottleneck was just iterating through every single tuple, every single 4 pairs, right? So I think since we can take advantage of this problem, we can iterate through every single 4-digit number.
Okay.
So, right, the first 4-digit number is 1,000, and then the last 4-digit number is 9,999. So clearly that's a lot smaller than our previous n choose 4. So right, if n was very large, then we'd be enumerating through a lot of numbers. But here, since one of the conditions is that it has to have 4 digits and it can't have a leading 0, just enumerating through these already knocks off those 2 conditions. And then another thing we can add is just, since we want it to be odd, we can only enumerate 1001, 1003, all the way up to 9,999. And so that would just be a little tiny optimization. And then from there, all we would have to do is, for each of these numbers, check if we can actually form them from the digits we have. So 0, 1, 2, 3, 0, 1, 2, 3, for this example, when we stumble upon the first number 1023, we're going to say, okay, 1 is in here, 0 is also in here, 2 is in here, and 3 is in here. So we would add that. But if we stumbled upon 1025, we would see that 5 is not in there. And then if we also had something like 1033, we would see that 3 is in there, but we have 2 3s and there's only 1 3. So what I'm planning on doing is enumerating through this string first, so digits, and then just recording the frequency of each character. And I would do that with a hash map. Then I'm enumerating through each 4-digit number and saying, okay, can I construct that based off of the frequency of the characters in here? And if there's a frequency in here that has, or if there's a character that has a lesser frequency than the number we currently have, so in this case, 3 only has frequency 1, but 3 has frequency 2 in here, then we would just ignore it. Otherwise, if it has the same frequency, then we can construct that, and we would add that to our answer.
Makes sense.
And the last thing that we would note is that when we construct the array at the bottom, since we're enumerating through each of these numbers in order, so 1001, 1003, up to 999, our final answer would already be sorted, so there's no need to do any sort of sorting algorithm on it. And so yeah, I think, I haven't written it out yet, but I'm pretty sure that this would be an O of n solution, since we're enumerating through digits once, and then we're just doing this constant operation of enumerating through these digits.
Makes sense.
So
just to clarify, you mentioned you want to keep track of the frequencies of each character.
Yes.
What are you going to do with them?
So let's just say for 1023, right? We have 0 mapped to 1, and then 1, also mapped to 1, 2, 1, and then 3, 1. So what we would do is we would extract each digit from here. So we would have 1, and then we would say, does the corresponding character have the same frequency in here as it does in here? So in this 1023, 1 has a frequency of 1. 0 has a frequency of 1, 2 also has a frequency of 1, and 3 has a frequency of 1. So since the frequency in the digits is greater than or equal to each one of these frequencies, then we can successfully construct this.
I see.
Yes.
Okay.
And then, like we said, 1033, in this case, 2 is 0, and then 3 is 2. We can get the 1 and the 0, but then, like we said, 3 is only in here once, and 3 is in this number twice.
Okay.
So we wouldn't be able to construct that.
I see. Makes sense. Yeah. Do you want to write the solution?
Sure.
Like just in pseudocode.
Yeah. So I'll just erase this first for a bit. And then I'll start. So here's the function. I'm just going to call it find digits. And then, yes, we're taking in digits. And like I said, we're going to have a hash map. So let's just call that hash map. And this is just going to be from, let's just say, int to int, int to int. And we're going to call this digits map. Then we're going to have our array called answers. And then we're going to begin the enumeration first of digits so that we can record the frequency. So for every single character, let's say in digits. And then we're also just going to assume that we can convert this character to an int and then map it in here. So first we're going to say if C is in digits map. If it's not, then we're just going to create a new mapping. So digits map from C, and we're going to say that has a frequency of 1. Or I'm sorry, if it's not in there.
Yeah.
Yes. Well,
Yeah, you can add a note in front.
I'll just go plus equals 1.
Okay.
And then else, it's not in there, so we're just going to say digits map C is equal to 1.
Okay.
So now we've mapped all the frequency of each one of these characters, and we're going to begin our enumeration. So for, let's just call this num equal to 1001 up to 9,999. And then we're just going to increment num plus 2.
Okay.
Yeah. So now we're incrementing and we're encountering every single 4-digit number that has no leading zeros and that is also odd. So now we just need to check. And let's just record the frequency now. So yeah, we're going to call this, we're going to just create another hash map. Hash map. And this is also going to be from int to int. And this is just going to record the frequency of each one of these characters. So int num map. Okay, so the first thing, there's two things that I think we can do to record the frequency. Either we can do some math to extract each character, or we can just go the easier route and just convert it into a string and then go through each character and then map that individually. So I think that'll be simpler to write out, so I'm just gonna do that instead. So
yeah, if you want to assume that it's a string, that's totally fine.
Okay.
You know, you can assume that like
Yes.
1001 is a string.
So for, let's just say character in num, then we're just going to go, well, we're going to do the similar thing here, except one of our conditions was that each digit needs to be unique. So if we do encounter something like a character that's already in this digit, then something we can say is, let's not continue to enumerate this and let's go to the next character.
Right.
Um,
So where are you planning to store all the numbers that actually satisfy these conditions?
I was going to put them in
Answers. Okay.
yes.
Okay. Makes sense.
Yeah. So well, now that I'm actually thinking about this, I think there might be like a slightly more optimized way as well, since each one of these needs to be unique. But I can bring that up at the end if.
Yeah, that's
yes.
fine. I
Yeah.
think.
So for each character in num, we're just going to have this hash map. And we're also just going to have some Boolean, let's just say, can add. And we're going to initialize this to be true at first.
Okay.
So what we're going to do is, if this character is already in the map, then we're going to say can add is false, since we want all the numbers to be distinct. So false. And then we're just going to break out of here. Else num map of C is equal to 0, or I'm sorry, not 0, 1. And then after we do this, we're just going to say if can add, we're just going to go if not. So if not can add, then we're just going to continue with this loop. And yeah, so that's the first part. And then we're going to want to check if the frequencies match up. So let's just say for int I in this num map, and this is just going to iterate through each key in the map. So if, like we said, we want the frequency in here to be greater than or equal to the frequency in num map.
Okay.
And so we're just going to continue to use this can add. So if digits map is actually less than, so if it has a lower frequency than in num map, then we cannot construct this number. So we say can add is false. And then we're just going to break. And then once again, we just check if not can add. And so I'm running out of space, so I'm just going to concatenate another one in there.
Okay.
So if we can't add it, and well, actually no, I think this is the only other statement we need. So if we can't add it, then we'll continue. Yeah, so I'm just going to re-go over what we're doing in this map. So we already know that these three conditions are satisfied since we're going through the 4-digit odd numbers with no leading zeros.
Okay.
And then what we're doing in here is we're checking if, first, if each one of these has a unique digit, if all the digits are unique. And then we're also checking if we can actually construct it. So we're just going through for each character, or for each key in the map, and then we're saying if this frequency in the digits map is less than the num map, and then I should just add an I there, just to make sure we're actually getting the frequency. So if the frequency in here, in the original digits map, isn't as large as a nums map, then we can't make it. So then we just say it's false, and then we break, and then we continue with the for loop so we don't add it. And otherwise, if it is, then we're just going to add that to answers. So answers dot add, and then we're just going to say num. And at the end, we're just returning answers. And like I said, we know that it's sorted because we're iterating through this in ascending order. And yeah.
Okay, makes sense. Do you want me to walk? Can you walk me through like one example?
Yeah, sure. I can just walk you through this one again.
This one is good.
Yes. So we have 0, 1, 2, 3, and let's just go ahead and iterate through each one of it first. So 0 has a frequency of 1. 1 also has a frequency of 1. And same for all the others.
Okay.
Then we begin our iteration of every single odd number.
Digits map, I believe,
oh,
right?
Yes.
Okay.
And so we begin our iteration of every odd number. And let's say we begin at 1001. 1001.
Okay.
So we begin to record the frequency.
Okay.
But then we see that the character 0 and 0, they actually repeat. So what we do now is just break out, and then we say continue.
Okay.
And we just keep doing this enumeration until we get to 1023. And we see, okay, each one of these is distinct. And then furthermore, these all have the same frequency as in the digits. So we have 1, 1, 1, and 1. So now what we do is we add that. And we continue to do this until we get to the next one, 1203. And then we also see that this is just rearranged, so they have the same frequency. And we begin to do that for every single other number that we encounter.
Okay, makes sense.
Yes.
So what would be the time complexity of this solution?
All right, so the time complexity really just happens right here. So since we're enumerating through each character in digits, this is O of n. And everything in here, I believe, we just make a hash map, and then we enumerate through each character in num. But this is still constant since num is always going to be 4 digits. And so yes, I believe everything else in here is also O of n, yes, since this is also just going to be 4 digits. So this is just O of 1 actually, since we're doing this constant enumeration loop, and everything else in here is O of 1. And then we're just returning answers at the bottom. So then the time is O of n, where n is the size of digits.
All right. Thanks, Matthew. This is great. Do you have any questions for me?
No, I don't think so.
Okay.
I mean, I guess how did I do? What could I have improved on?
I think you did very well.
Awesome.
Probably, I think this question can also be done using sets because, although this is absolutely right, but
yes,
it could be a little bit more optimized. But overall, you did phenomenally well, and I hope to see you in fall. Aim for the class.
Wow,
you're
thank you.
hired.
Thank you. I mean, I accept.
Nice
Thank
to see you.
Nice. Thank you.
Take care.